Somewhere in your family tree, 74,000 years ago, there was a woman who watched the sky turn the wrong color and did not know if her children would see another summer. She wasn't imagining it. The sky actually did turn. And what happened next came closer to erasing our entire species than almost anything else in human history. Not a war, not a single predator, a mountain. Here's the number that should stop you cold. Some scientists who study ancient human DNA believe that at one point, the entire population of Homo sapiens on Earth, every person who would ever become your ancestor, may have dropped to somewhere between 3,000 and 10,000 individuals. Not 10,000 in one region, 10,000 total on the whole planet. Fewer people than fit in a single football stadium, carrying the entire future of humanity in their bodies, and not knowing it. So what does that to a species? What almost finishes off the most adaptable animal on Earth before it even gets started? The answer began with a volcano called Toba on the island now known as Sumatra, and it detonated with a force that modern science still struggles to fully describe. This wasn't an eruption the way you picture eruptions. This was a supervolcano, a category of events so rare that only a handful have happened in the last few million years. When Toba went off, it didn't just destroy the region around it. It punched an estimated 2,800 cubic kilometers of rock, ash, and gas into the sky. Enough material to bury an area the size of a small country under meters of debris. Ash fell as far away as what is now India and East Africa, thousands of kilometers from the source, drifting down on people who had no idea what had just happened to the sky above them, or why. But the ash falling to Earth wasn't even the real danger. The real danger was what happened after, high in the atmosphere, where the sun used to be reliable. Volcanic eruptions of this scale throw sulfur compounds into the stratosphere, and those compounds form a fine haze that spreads around the entire planet, reflecting sunlight back into space before it ever reaches the ground. Some researchers have proposed that Toba triggered a volcanic winter, a stretch of years where global temperatures dropped, growing seasons shortened or failed outright, and the delicate math that every hunter-gatherer group depended on, enough food gathered to survive to the next season, simply stopped adding up. Picture what that actually meant on the ground. You wake up and the sun is dimmer than it should be. The plants that fed you last year are stunted this year, or don't come up at all. The animals you tracked have moved on, following food that no longer exists where it used to. And this isn't a single bad season you can recover from. Some estimates suggest the cooling and instability may have lasted years, long enough that an entire generation of children grew up not knowing what a normal sky looked like. This is where the first real test began, and it wasn't strength. It was information. Groups that survived this kind of prolonged collapse weren't necessarily the biggest or the most aggressive. They were the ones who knew the landscape intimately enough to find the exceptions. The sheltered valleys where a few plants still grew. The deep water sources that hadn't dried with everything else. The coastlines where shellfish didn't depend on sunlight the same way crops did. There is archaeological evidence from coastal sites in southern Africa, some of it dated right around this catastrophic window, showing people relying heavily on shellfish and marine resources. A food source that doesn't collapse the same way a grain harvest does when the sky goes gray for years at a time. The humans who thought to look at the coastline instead of only the plains may have quietly outlived the ones who didn't. That's the first survival mechanism. Not brute force. Flexibility. The willingness to abandon what used to work and gamble on something new, fast, before the old strategy finished starving you. Picture one of those coastal groups directly, at a site now called Pinnacle Point, on the southern tip of what is now South Africa. Archaeologists have found layers of shellfish remains, ochre, and stone tools, dating to right around this window, tucked into caves overlooking the sea. Imagine a family there, timing their mornings not by a clock, but by the tide itself. Walking out onto exposed rock only when the water pulled back far enough to reveal it. Prying mussels and shellfish loose with nothing but a sharpened stone and patient hands. It was slow work, unglamorous work. Nothing like the drama of a mammoth hunt. But the ocean didn't care what the sky looked like. The tide came in and out on schedule, whether the sun was dim or bright. And that quiet, boring reliability may have been the single most important resource on the entire continent during those years. The people who noticed that, who were willing to build a whole way of life around scavenging rock pools instead of chasing herds across a dying plain, weren't just adapting. They were quietly rewriting what it meant to be human, one low tide at a time. But finding food during a collapse only solves one problem. The deeper threat came from what a shrinking population does to itself. When a species' numbers fall this low, something happens that has nothing to do with predators or weather. It's genetic. Every surviving population carries the accumulated diversity of everyone who came before it. All the small variations that let a species adapt to disease, to new environments, to future disasters nobody's seen yet. When a population bottlenecks down to a few thousand individuals, most of that diversity simply vanishes, because it lived in the bodies of the people who didn't make it. Modern genetic studies of human DNA have found signs consistent with exactly this kind of bottleneck around this period. A genetic signature suggesting our entire species passed through an extremely narrow surviving population before expanding again. In other words, every single human being alive today, every ethnicity, every continent, every language, may be descended from that same small handful of survivors who made it through those years. That fact alone should rearrange how you think about other people. There is no group of humans on Earth today that is more distantly related to that surviving population than any other. We are, genetically, remarkably close cousins, because we all came from the same terrifyingly small starting point. But a shrinking population creates a second danger, a quieter one. And this is the one that could have finished the job, even after the ash settled and the sky cleared. A small population isn't just fragile because of missing genes. It's fragile because there are fewer people to do everything a group needs done. Fewer hunters means fewer successful hunts. Fewer elders means less accumulated knowledge about which plants heal and which ones kill, about where water hides in a drought, about how to read a coming storm. Every single death in a group this small wasn't just a loss of one person. It was potentially the permanent loss of a skill, a memory, a piece of the survival manual that existed nowhere except inside that one person's mind. Lose enough of the wrong people, and a group doesn't just get smaller. It gets stupider, in the most literal survival sense. Right at the exact moment it can least afford to be. This is almost certainly why the groups that made it through weren't isolated. Genetic and archaeological evidence increasingly suggests that surviving human populations stayed connected across distances, trading, mixing, moving between groups, rather than hardening into small, isolated pockets. A small, isolated band was one bad season away from extinction, with no outside population to reinforce it. A network of small bands, loosely connected, trading people and knowledge and occasionally mates, could absorb a disaster in one location without losing everything. Isolation was a death sentence. Connection, even thin, occasional connection with strangers from another valley, might have been the actual difference between a species that continued and one that quietly ended. Which brings us to the part of this story that almost never gets told, because it isn't written in ash layers or DNA. It's written in what must have been happening around every fire during those years, in every gathering of people who didn't know if their species had a future. Try to imagine living through this without knowing it would end. You don't know it's called a supervolcano. You don't know it's temporary. You don't know that in 74,000 years, some distant descendant will calculate the odds and explain it to a screen. All you know is that the sky is wrong, the food is disappearing, and the group around you is getting smaller every season. That kind of uncertainty, stretched across years, is one of the heaviest weights a mind can carry, and it fell on every single person who lived through it, from the oldest elder to the smallest child. And yet they kept going. They kept teaching children which routes were safe. They kept passing down which star patterns meant a storm was coming. They kept choosing, deliberately, to share food with someone outside their immediate family, an act that made no cold biological sense in a moment of scarcity, except that it might be exactly what kept the whole species threaded together long enough to recover. Because recover, eventually, we did. The ash settled. The sun came back in full. The population that had shrunk to a number small enough to fit in a single village began to grow again, slowly, and then not so slowly, until those same descendants walked out of Africa and into every corner of the planet, into deserts and ice fields and mountain ranges and islands no human had ever seen. Every person who has ever lived since is the result of that recovery. You are the result of that recovery. So here's what's actually strange about this story, the part worth sitting with. We tend to think of near extinction as something that would leave a species broken, diminished, permanently scarred. And yet the population that came out the other side of Toba's winter didn't just survive. Within tens of thousands of years, they had spread across every habitable continent on Earth, adapted to more environments than any other large mammal in history, and eventually built cities, written language, and sent machines to other worlds. Maybe that bottleneck did something you wouldn't expect. Maybe living through a disaster that size, generation after generation, quietly selected for exactly the traits that would matter most later. Flexibility over rigid habit. Cooperation over isolation. The willingness to abandon a failing strategy and try something unfamiliar before it was too late. Every one of those traits sounds oddly familiar, because you still carry every one of them, whether you've ever had to use them for actual survival or not. You have never seen the sky turn the wrong color and wondered if your species would make it. You will probably never have to. But somewhere in the deep architecture of what makes you human, in the instinct to check on people outside your immediate circle during a crisis, in the strange comfort of hearing that other places are still doing fine when your own world feels like it's collapsing. In the simple fact that you are reading this at all, there is a small, quiet echo of 3,000 people who refused to be the last chapter. They didn't know they were the bottleneck the whole species would have to pass through. They just knew the sky was wrong, and they kept the fire going anyway. Every single one of us is the proof that it worked.